Hi, welcome to In and Around Computer. In this video, we are going to see the types of multi-threading. Multi-threading in operating systems can be categorized into several types based on how threads are managed and executed. Here are some common types. If you want to know what is multi-threading, you can check my video in my channel. And now we can see the types of threads, and first is the user level threads, and these are managed by the user libraries. That is, these are managed by libraries at the user level, not by the kernel. And this means the operating system kernel is unaware of these threads. And the advantages here are they can be implemented on any operating system. They are generally faster to create and manage since they don't require kernel mode privileges. And the disadvantages here is that if a user level thread performs a blocking operation, the entire process blocks since the kernel isn't aware of the individual threads. So this is a type of multi-threading which involves the user. Next type is the kernel level threads, and these are managed by the kernel. That is, the operating system kernel is responsible for the thread management, and each thread is treated as a separate entity, or we can say each thread is a process. And this will be explained in the video of multi-threading in my channel. And advantages are because the kernel knows about each thread, it can schedule them independently. This allows one thread to be blocked while others continue to execute. Disadvantages here is that creating and managing kernel level threads require more overhead and is slower than user level threads. And this is a type of multi-threading. And next is the hybrid threads. And the combination of user and kernel level threads are known as the hybrid threads, and this multi-threading model combine aspects of both user and kernel threads. That is, the common implementation is a many-to-many model where multiple user level threads are mapped to multiple kernel level threads. And the advantages here is that this approach aims to balance the benefits of both user level and kernel level threading, offering better performance and resource management. And disadvantages is that this model is more complex to implement and can lead to more overhead in certain cases. And next is the many-to-one model, and multiple user threads to one kernel level thread. That is, in this model, many user level threads are mapped onto a single kernel thread. And advantages are that simple to implement and manage, and no concurrency is possible within the same process. And disadvantages is that if one thread blocks, the entire process blocks because there is only one kernel level thread. That is, here in this model, many user level threads are mapped onto a single kernel level thread. So if one thread blocks, the entire process blocks because there is only one kernel thread. And next is the one-to-one model. And here one user thread to one kernel thread, that is, mapping is between each kernel level thread maps to a kernel thread. This one-to-one mapping. Here the advantages is or a true concurrency is possible because each user thread has its own kernel thread. And the disadvantages here is that can be resource intensive, as creating a large number of threads may strain the system resources. And next is many-to-many model. And here many user threads to many are multiple user threads are mapped to an equal or fewer number of kernel threads. Here the advantages are balances the advantages of many to one and one to one models, that is provide better resource utilization and performance. The disadvantages here are more complex to implement and manage. So these are the types of multi-threading based on the threads, and subscribe to my channel if you feel content.